Hi there, grade 6. I'm going to go through the unit review with you today. So I'm using a little bit of new technology here. I hope it works well for you. And you can see some of my work to help you with some of your work. So I'm going to do Unit 4 review. And I've attached this to the Google Classroom and I've emailed this out to your parents. And you can either print it off, or if you just see it on a computer screen or a tablet or something, you can just refer to the questions and then work on a scrap piece of paper beside you like this. And I know for some of these questions you might have to do some measuring, so it is helpful to print it, but I guess you could always use your protractor on your computer screen if you had to. Just be really careful and smart about that when you do. It is best if you could have a paper copy printed out. This is in the textbook, so it's on page 154 and 155. And so if you have your textbook at home with you, awesome. Let's just use that. If not, see if you can get it printed off. So let's go through each of these questions and I'll try to give you some assistance. Now, as with anything, this is a review, so it is best if you could do this question on your own first, and then when you're stuck, you refer to some of my explanations or assistance. And if you're done, maybe you just use this as a double check to see how you're doing. So, the first one here, it says, identify as many different angles as you can in the signs below. Name each angle as acute, obtuse, right, straight, or reflex, and then tell how you know. Describe the location of each angle. So, number one, you're probably going to want to have a protractor with you for most of the work that we do here today. So have a protractor and maybe a ruler or a straight edge of some kind, okay? If you can work with a pencil, it's probably good. I've got a pen for now. When I make mistakes, I'll probably have to scribble, but if I have a pencil, I can just erase and go on. So, name the angle. So when I look at the stop sign here, well, I can see an angle right here. Okay, so this angle is actually the same all the way around, but I would call this obtuse. So it's bigger than 90. 90 would mean it goes straight up here. And it's not straight. A straight line would come straight out here. And it's not a reflex where it goes around greater than 180. It's over, up, right here. So I would call that one obtuse. All of these around the outside look like they're obtuse. If I looked at the letter T, I could see the corner of the T looks like a right angle, 90 degrees. I don't really see, now remember, in order to get an angle, you need two straight lines. So O and S have no straight lines. P, I guess you could say like the bottom corner on the P here could be a right angle. I don't see any other angles there. I guess you could actually say this is a straight angle, the top of the T. Okay, it's a straight line. So any straight lines. Now usually you still need to have 2 points, but quite often a straight line is good enough to make a straight angle. Well, I look over here at this one, and to be honest, this is not a vertex. This is a rounded edge here. So in order to get a vertex, I need a square edge. Whether that square edge is small or big, it still comes to a point. And if I don't have a point, like this is a curved edge, that's not a point. But I look at the letters NWT, and I see lots of angles in there. And I think the angle in the N here, okay, so if I make a little bit bigger N, this angle here, or this angle here, those look like acute angles to me. They are smaller than 90 degrees, because remember, 90 degrees makes an L shape. That's 90 degrees. These would just be acute. In a W, okay, I also would say that these angles are acute. This one here, depending on how you drew the W, if you drew it a little bit wider, This could be a 90-degree angle, or it could even be wider if you made it like this. So that W, I think this angle is obtuse. So it all depends on what you think this W is making. I think the picture here looks acute to me. And of course the letter T, okay, you've got a 90-degree angle, so we would call that a right angle. Looking over here at this sign, now the corners of this sign, they look like they're square, so that would be right angles. Okay, those would be right angles. The number 7 only has one straight line. This line is curved, so it does not make an angle. But these little yellow and black stripes here, they're making angles with the top and the side and the bottom. And I think that most of these angles are obtuse. Now it says, tell how you know. It says, tell how you know right here. Well, first of all, I could extend some of these lines, and I could measure them with a protractor. So for this stop sign, if I wanted to go like that, go like this, I've now extended that angle. I can put my protractor on it, and I can say, hey, look, that looks to me like it's about 130 degrees, okay? Gets to be about 130 degrees. So 130 is greater than 90. And remember, right is 90, obtuse is 90 plus, acute is less than 90, straight is 180, and a reflex is 180 plus. And so obtuse would be 90 plus. I got 130. Okay. So anytime I want to prove it, I could use either a protractor, or I can just go to my notes and use this information to prove it. So that's some of the ways I can see and find and label angles in those. Number 2, it says draw a line segment on grid paper. Okay, well I don't have grid paper, but I think I can draw a line segment. So a line segment is simply just a straight line. It has a beginning and it has an end. So there's my line segment. I'm going to put 2 little dots at the end. And now it asks me visualize rotating the line segment about one of its points, endpoints. So I'm going to say that this endpoint can't move, but this one can. So it can rotate around in a circle to make different angles. Now, instead of visualizing, I'm actually going to draw some of these so that you can see what I'm talking about. Okay, here it says visualize what happens and what kind of an angle is formed when you turn it a quarter turn clockwise. So remember, a clock turns in this direction. Okay, so if I take this and I imagine that it turns a full turn, would mean it comes all the way around and back to where it is, which means a quarter turn, it would stop down here at what I would call the 3 o'clock position. So where's my straight edge here? It would be like taking this, holding my pen or pencil here, and then rotating this guy at that point a quarter of a turn. And what does he make? Well, there's a quarter of a turn. Look, that looks like a 90-degree angle, so it makes a right angle. What happens if I turn it between a half turn and a full turn? Well, again, if I get my ruler on my line segment, hold my pencil, and I start to turn my ruler around that point, there's a quarter. Now it's turned a half, and let's say it's between a half and a full turn. So now I'm going to go here. Now, what does that look like from our starting point? Well, it's gone all the way around to there. Well, to me, that looks like a reflex angle, because reflex is greater than 180. 180 would be if I was pointed straight down here. And it's great. It's gone greater than that. Okay. What happens, it says, if it goes between a quarter and a half? Okay. Let me just draw another line segment here to make this a little more clear. So there's my line segment. Let's say that I go between a quarter and a half. So there's a quarter, There's a little bit more, not quite a half. Okay. Oh, what does this look like? Well, that looks like an obtuse angle to me. So greater than 90, less than 180. Obtuse. What if it's less than a quarter turn? Okay, so let's go back to our starting point. And we go less than a quarter. So let's go right there. Well, what does this angle here look like? Well, that's a small one. We call that acute. Oops. Acute angle. Okay, so this guy here is an acute. This bigger guy here, obtuse. So that's kind of how you want to try to go about number 2. And so your answers are going to be words like right, reflex, obtuse, acute. Excuse me. You don't have to draw them like I did. It just wants you to tell them which type of angle is formed. I just felt this helped with the explanation. Okay, number 3. Owen says he can make an angle smaller by making the arms shorter. Do you agree? Why or why not? Well, I'm going to get my pencil out for this one because I think that'll help me. So let's try it. Let's make an angle. Okay, so here's an angle. It's got 2 lines and a vertex. So this is the angle. Now he's saying he can make this angle smaller by making these 2 arms shorter. So let's see if that happens. Well, first of all, let's measure. Okay. So it looks like I have an angle of 50 or 51. It's right in between those two. So I would say it's about 50 or 51 degrees. Now, what happens when I make my arms shorter? Okay, let's see if that changed the number at all. What do you think? I'll let you think about that one while I measure. And you're going to notice it has not changed. It's still just between the 50 and the 51. So it's still the same number of degrees. So when they ask this question number 3, do you agree? I hope you do not agree with him. Why or why not? Because you haven't changed the opening by making the arms shorter. You can make the arms as long as you want. The angle here is not going to change, right? Okay, how about question number 4? For each angle, choose an appropriate reference angle. So this is like estimating, okay? We've done some estimating and benchmarking and things like that. Reference angles are estimating. 45, 90, or 180. So first you're going to estimate. Next, use a protractor to actually measure it. Then, order the angles from least to greatest. Then, name using these words. Okay, well that shouldn't be too terribly hard. Let's get to another piece of paper. Okay. First of all, let's. I'm going to write right on this piece of paper, but you're going to probably do it on a different piece of loose leaf. So you're going to say choose an appropriate reference angle. So when I look at this guy, I think it's closest to 90. I think this looks pretty close to the corner of a square or a rectangle. B, I would say, well, I guess it's closest to 180. I don't think it is 180, but it's closest. It's not as close to this, and it's definitely not very close to that. C, it's right in between these two. So I would say like a 90 is about here, and a 180 is about here. So it's kind of in between them. So none of these are really great reference angles for this one. But, oh, sorry, I guess we're supposed to estimate the size. So here's what your answer would look like on a piece of paper. You're going to probably go like this. 4A. Estimate. I say that looks really close to the 90, maybe a titch smaller. So I'm going to estimate 88 degrees. Use a protractor to measure it. So let me jump in here with a protractor. and I guess it's right on 90. So I got the 0 on my 0 line, I got the center on my center X here, and the line goes straight up underneath this 90. I'll just kind of rotate it so you can see that line right there. And when I get it all lined up perfect, the two lines disappear because they're right on 90. So then my actual is 90. Order them from greatest to least. So I'll do that, from least to greatest, and I'll do that later. And then my name of it is, well, it's a right angle because it's exactly 90. So this is what your 4A would look like. Then you'd do 4B, and you'd do an estimate, an actual, and a name. And when you got to the end, you would order them, okay? And you're going to do the letter. There's 6 of them. So you're going to have an order of the smallest one will go first. And I'll get that once I'm done all of these. So let's go on to B. So using these reference angles, what do I think this is? Well, it's closer to 180 than 90. 90 is up here. So I'm going to say this is about 165. I'm going to estimate 165. So 165 is my estimate. I get my protractor on here. It doesn't matter if I line my 0 up with this, or if I line my 0 up with that. I'm going to get the same answer. Okay. Oh, it's going out here at about 150. 150. So my actual is 150. And a name, that would be an obtuse angle. It's greater than 90, but less than 180. So that's an obtuse angle. Okay, let's do C. So my estimate, my actual, and my name. So C, my estimate, well, let's see, it's right in the middle between 180 and 90. I kind of decided that earlier. So the middle would be another 135 degrees, I guess. I'm going to estimate 135. And when I get it on here, it looks like it's right on the 130. 130 is my actual answer. I could have done it this way too, and I'd get the same answer. I'd still get 130. Okay, and the name of this, well, again, it's bigger than 90 and less than 180, so we call that obtuse. Okay. Now this guy down here, he's a little bit trickier. D, our estimate, our actual, and our name. Well, my name is actually reflex. You can see how it goes almost all the way around. If it's past the 180 mark, so a straight line's 180, if it's past that, we call that reflex. So reflex is the name. Now, how do I measure this with only a protractor that goes from 0 to 180? Well, that's really difficult, right? I could actually use my full circle protractor to do this one. However, it's going to be hard for me to measure it because this line doesn't get to my numbers here. I would be guessing. So there is a different way. What we can do is we measure this portion and we just subtract it from 360. So let's get the measurement of the smaller portion. Now where is it here? It's right there. Right here. It's 40 degrees. Okay, so this is 40. Therefore, 360 minus 40 leaves me with 320. So, oops, I was supposed to estimate first. I didn't estimate first. I probably would have guessed around 300 degrees when I look at that. And so that's pretty good, 320. Now, let's do a quick little, see if we can get this using our full circle one. So I'm going to extend my lines. you can see I'm not changing the angle by making them longer. The angle is still the same. But let's get this guy on here to see if we actually get that 320 degrees. So it's getting lined up with the 0 here. And my center is at the vertex. And what do we got? 320 degrees. So there's that 40/320. It goes all the way around to 320 degrees. Okay, so neat. If you had a full circle protractor, you can use it. If not, you can still use the old half moon, half circle. Okay. Letter E. Estimate actual name. So let's estimate first. This looks like it's about half of, well, maybe a little less than half of a full 90 degrees. So let's say 30. Okay, we're going to guess it's 30. Estimate it's about 30. And now we're going to get our protractor on here. And I'm a little less than 30. I'm going to have to extend this line in order to be able to measure it on my protractor, because it doesn't actually get right through where I want it to. So I'm going to extend that line, get her all lined up again, and it looks like it's about 20, 25, 26, 27, 28 degrees. So it's about 28 degrees, and I know that that is an acute, oh boy, I have trouble spelling acute here, don't I? It's an acute angle. Okay. And F, last one. Oh boy, this one looks like it's almost a straight line. A straight line would be 180. This is just a little bit off. So I'm going to say maybe, well, let's guess what, 175? Okay, let's get the protractor on it. Oh, I'm going to need to extend one of these lines. Let's extend this line here. Okay. And now I'm going to get my protractor right in the center as well as I can. And it looks like it's actually right on 170. Right here through the 10 and the 170. So my actual answer is 170. And it is bigger than 90, but less than 180, so we still got an obtuse angle. Okay, so now let's look this over and see if we can order them. Smallest, 28, is our smallest, so E. And then 170, 320, 130, looks like 90. So A. 130 was C. 150 was B. 170 was F. And D was 320. So there's the order from smallest to largest. Okay? That's what question 4 should look like in your book or in your answers. Okay, now we flip it over. We get to the back side. It says, a student has used a protractor over here, and they say that this angle measures 65 degrees, because you can see it goes right through where 65 is. It's a little blurry for you there, right? Okay, so it asks you, is the student correct? Well, I think if I was you, I would say, I'm not sure if they're correct, because they did not measure the angle properly. I guess it's possible that they lucked out and got it correct, but remember this point right here, okay, that needs to be at the vertex, and the vertex, they've got it way over here. So I don't know if they got this right. If your answer is yes, explain how you know. If your answer is no, describe their mistake. So their mistake is where they lined up their protractor. Now let's see if they actually got it right. I kind of doubt it, but so if we get our 0 on the 0 and our center on the center of the vertex, it actually looks like it measures 40 degrees. A 65 degree would have been right about there. A 65 degree angle would have looked something like this. Okay, so that's 65, that's 40. So they measured it incorrectly because it wasn't on their vertex. Okay, the next one. Use a protractor to draw a line. So let's draw a 40-degree angle. Do not use a protractor. Draw an angle that is 90 degrees greater. Describe the strategy you used. Use a protractor to check. Oh, okay. So we're going to draw an angle that's 40 degrees. In order to draw an angle, we need an initial line. So there's a line. And I'm going to say that this is my vertex. And now I need a protractor. I get the 0 on the vertex. I get the center on the vertex, and my line goes through 0. And it wanted a 40 degree to start. So right here is the 40, 140. So I'm looking at this 40 degree, and I'm going to put a little mark. And now that I have 2 points, I've got my vertex and this little mark. I connect them. Okay, I have just created a 40 degree angle. Now it says, throw this thing away. You can't use this because this would be too easy to make that 90 degree angle, right? But it says, draw an angle that is 90 degrees greater than what I just did. So how am I going to do that? What can I use? Well, maybe I could use this ruler right here. Maybe I could find something that I think is a square. So I got some Post-it notes here that have a square angle. Or I've got a textbook here that should have a square corner to it. Or what else can I find sitting around me here in my desk? I've got a card here that I can see has a 90 degree angle. Got all sorts of things. I'm just going to use my Post-it notes here. And if I keep the vertex the same and I rest this edge on my 40 degree line, okay, and I get it lined up nice, I should be able, maybe I'll go through, just make sure I'm going to get right on that vertex. Oh, there. How does that look? So does this look like I just created an angle that is 90 degrees greater? Well, I think so, but let's check. What's 40 plus what I think is 90? 40 plus 90 equals 130. So let's see if I made a 130 degree angle. Yep. Looks really good, really close to 130 degrees, so I just made it 90 degrees bigger. Okay, and so the point of this is to just let you know there's so many things in our world around us that are 90 degrees. And so understanding right angles, 90 degree angles, they're very common all around us. Okay, number 7, it says copy these line segments, use a ruler and a protractor, using each line as one arm. Draw a 125 degree angle. Okay. Well, let's get out another piece of paper here. And I don't know, can I see? Yeah, I guess I can see that through the paper. Let me get some grid paper here though. Let me see if I can see it through the grid paper. That's pretty good. So, excuse me. What I want to do is I want to be able to hold the grid paper right flush with the edge. Oof. So I want the edge of my paper here, right here, in line. Then I'm going to get my ruler and I'm going to push down nice and hard so that I can copy this line. So this line's right here. This line is right here. And this line, I see it right here. Okay, so I've just copied those 3 lines. You can see they look pretty similar. And it now wants me to use a ruler and a protractor and make an arm that's a 125 degree angle. Well, here's my protractor, and I've already used my ruler to make these 3 lines, so let's just go ahead and give this a try. Now the question is, where do you start? Where's your vertex? You actually have 4 options for each one. So you could have this as a vertex or this as a vertex. And if this is my vertex, I could hold my protractor like this, or I could flip it upside down and I could hold it like this. And then I have the same 2 options here and here. So what I have to decide is, where do I have room? And it looks like I actually have more room down this way. So I'm going to flip my paper upside down. I'm going to use this as my vertex. I'm going to put my protractor on it here. And I'm going to put, as the 0, I'm going to count out to 125 degrees, 120, 130, 125 is right in the middle. And now I'm going to connect the dots from my vertex through that line. Okay, I just created a 125 degree angle. Now, I'm going to let you do these other 2. Okay, you don't need my help to do that. You just use the same method I did. And it asks you, does the position of an angle on the page affect its measure? Explain how you know. Well, once you do all of these, once you actually get all these done, so I'm going to do this one just to show you, 125. And the answer should be no. It does not affect the angle. The angle is still the same. So this is still 125, this is still 125, and the angle that you make over here somewhere is still going to be 125. It doesn't matter where this line or this line or this line, if it was a straight horizontal line and you did 125. The angle itself is still the same. So it doesn't matter where the starting line is, it does not affect the angle, does not affect the measure of the angle. Okay, a couple more questions here. Use a ruler and a protractor, draw, then label each angle below with its measure. A right angle, an acute angle, and an obtuse angle. Okay. Let's draw a right angle. Now I can use a little bit of a trick here. I don't really need a protractor because I've got graph paper. And so I can draw a right angle by just using the blue lines. And as long as I stay on a blue line, I know I just created a right angle. If I wanted to create a, excuse me, if I wanted to create an obtuse or an acute angle, I can actually continue just to use my, my grid paper. And I know that straight up is right, and anything less would be acute, so I'm just going to go less, and whoop. I'm going to make that a little bit nicer looking. Okay, so that there would be an acute, less than 90. And I'll make one more here. Again, as long as I know that this is right, and anything going in this direction is going to be obtuse. There. Obtuse. So I've created those 3 angles. For each angle in part A, join the arms together to make a triangle. Oh boy, okay. So, I don't know if I've left myself enough space. Pretty close. There's one. There's 2. And here is 3. Okay, so I've now made 3 triangles. They've got right, acute, and obtuse. Oh, I forgot to label the measure. It says draw, then label each angle below with its measure. Okay, well, we know that this one's 90 degrees. Let's see what, where did I put my protractor? Here it is. Let's see what this angle is. It looks like it is about 28. I'm going to call that 28. And this angle here is right on 140. 140. Perfect. Okay. So you've all measured one of those angles that you did, labeled it, draw, label, and measure. Okay. Now I join them together, measure and label one of the other angles. Okay. Well, let's measure it. I'm going to measure this one down here. It looks like it is, oh boy, it's really close to 30. It looks like maybe 31. 31 degrees. This one here looks like it is about, whoops, a little less than 30. I'm going to say it's about 28 as well. Looks like I got a nice equal angle here. Isosceles. Okay. Now we're going to go over like this. Oh boy, this one looks pretty small. It is between the 10 and the 20 right in the middle, so 15. Okay, so I've done that now. I've got two labels on my triangles. Without using a protractor, label the third angle with its measure and then explain how you did that. So, how do I know what this is? I'm going to label it with a letter X, X, and X. I don't know these ones. I'm not going to use this protractor. I'm going to throw it away again. And I know, you know, that each triangle has 180 degrees. So if I subtract what I've got, in this case, 90 plus 31 is 121. If I subtract that, I should be able to get my answer. So this is 59 degrees. Over here, 28 and 28, so you can do some mental math, use a calculator, do the actual math on paper. I'll leave that up to you. 56. I wanted to give you a second there. Okay, 180 minus 56. Again, use a calculator if you need to, but doing some math on paper is always great. Great to test your brain and build your skills. So we have to borrow. And that means that this angle right here is 124 degrees. Okay, how about this last one? Do you think it's going to be a big one or a small one? Looks like it's going to be a smaller one. 140 and 15 is 155. So if we've got 180 total, we've got 155 already used. Let's just subtract, and we get 25. Right? We have to borrow 5, 2. Okay, so 25 degrees. That's that angle. Okay, so explain the strategy that you used. Well, I used the idea that every triangle has 180 degrees in it, and if I subtract what I have, the result should be the missing angle. Okay. Question number 9, exact same thing. You're given 2, find the third. So I'm not going to do this one for you. You should be able to do this. You got to add these up, just like we did in our assignments this week or last week, and subtract them from 180. So 70 plus 25 is 95. 180 minus 95 should leave us with about 85. Okay, you do those. Now, question number 10 is about quadrilaterals. We did one lesson on quadrilaterals at the end, and we learned that a quadrilateral has 360 degrees when you add up all the angles. Well, it says this has 60, 50, and 120 on 4 of its angles. What is the fourth angle? How do you know? Well, hopefully you added up 60 plus 50 plus 120, and you got an answer. Whatever that answer was, you should have went 360 degrees, subtract that answer, and that's going to give you your missing side. I'm going to let you do the math. And when it says, how do you know? You know because every quadrilateral has 360 degrees. So we need to know that concept. Okay, I hope that helped you with your review here. Again, I hope you kind of stopped the video as you listened and tried some of these questions on your own and used it for help. I hope that's what it did for you, and I'm looking forward to seeing you next week, and we'll do a quick review in class before we move on. Good luck.